74th Chaitra, it is a set from 74th Chaitra I have picked, and it is irregular, so it will be more helpful to you. The question is asked. You can see question from the preview on the previous side. Question is asked, state Lebanese theorem. So we will do first state. It states that if u and v are the function of x, then the nth derivative of their product is given as un uv n is equal to nc0 unv plus nc1 un minus 1 v1 plus dash 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 plus ncn uvn. And this is the statement of Lebanese theorem. Now next question is attached. Now given log y is equal to tan inverse of x is given, so we take derivative of it 1 upon y, y1 is equal to 1 upon plus x of a square, or 1 plus x of a square, y1 is equal to y. Now what we are gonna do, we are gonna solve it. Again we need y2 is by the question, so what we are going to do, we are going to differentiate it again. Y2 plus 2x y1 is equal to y1. Or now see here, something is wrong. You may be correct. Something is wrong. No, nothing is wrong. I thought it was wrong, but it is absolutely correct. Now what we do, we use Lebanese theorem. Lebanese theorem for nth times we get what we get. We get 1 plus x square and y n plus 2 plus 2x and y n plus 1 plus 2n n minus 1 upon 2 y n plus n is equal to or plus next to x y n plus 1 plus 2n y n. We take this on this side and we do its differentiation also. Y n plus 1 is equal to 0. Now what we do, we take common on the same side. 1 plus x square y n plus 2 plus all y n plus 1 on the one side, y n plus 1 2x n, and the next y plus 1 we have got here 2x plus 2x, another y plus n, here we have got minus 1. Then we will take y n term we will take. Here is y n term and here is y n term, and 2n is common, but we this and this can be cancelled, and here is n, here will be minus n, so it would add up to what it would add up to. It would add up to n square plus n y n is equal to 0, and this is asked to prove. We proved it. Now let's move to our second question. The second question asked is state Rolle's theorem. First we are going to write a statement of Rolle's theorem. What is a statement of Rolle's theorem? Statement of Rolle's theorem. Rolle's theorem states that if a function f(x) is continuous on a comma b and differential on a comma b, then it also satisfies for fa is equal to fb. There exists a point C belongs to a comma B such that f dash C is equal to 0, and this is the statement of Rolle's theorem. The next question that is asked question is, it is asked, is the theorem true when the function is continuous at the end points, when the function is not continuous at the end points? No. Why no? The function is or does not satisfy the Rolle's theorem. We'll read why theorem. Why? Let's draw a chart. Let's draw a curve. Let a curve be y is equal to fx. We have a curve y is equal to fx. These are tangents. This point is C, this point is A. Let this be x is equal to A, and this end point B, x is equal to B, and this point V, x is equal to C. Now for Rolle's theorem, FA is equal to FV. FA is equal for Rolle's theorem. For Rolle's theorem, FA is equals to FB. But if FB is not continuous, then FA will not be equal to FB. Hence, theorem is invalid for this case. Now we move to our next attached question. This is from the same question, and it has asked to verify the Rolle's theorem. And to verify a question is given, what is given? f of x is equal to x square minus 5x plus 6 on 2,3. This question is given. We have to solve it. Solution. For Rolle's theorem, since this is a polynomial, this is polynomial equation, so it is continuous and differentiable. So f dash c is equal to 0. We have find the first derivative of fx. F dash x is equal to 2x minus 5. So f dash of c is equal to 2c minus 5, or 0 is equal to 2c minus 5, or c is equal to 5 by 2. This is equal to 2.5. so here is the given limit is given, to range is given 2, 3, so it lies between these 2 points. Hence the Rolle's theorem is verified. Now we move to our third question. And what is our third question? By mean of third question, the question is given state L hospitals rule. Then we are going to state L hospital rule. Solution: what does L hospitals rule? State L hospitals rule. State for a continuous function at x is equal to a and f x is equal to f a limit x tends to a f at a limit x tends to a f of x by f of z is or g of x is equal to f dash of x by f z dash of x, and here limit is missing. Limit x tends to a, and this is equal to f dash of a by z dash of a, where z dash a not equal to 0, because if it is 0 then it would not be valid. And the next question asks to evaluate limit x tends to 2, x tends to 1, 2 minus x to the power 10 pi x by 2. How can we do this? Let y is equal to limit x tends to 1, 2 minus x power pi x by 2. Every time you see this type of question in power, then you use log on both sides. Log y is equal to limit x tends to 1, this comes down, it becomes 10 pi x by 2, and log of 2 minus x. Or now what we do, we check on the other side whether it is 0, 0 or not. Here 10 pi x by 2 is given. When we put value of x as 1, what does it happen? 10 pi by 2 is infinity into this is infinity, so we have to make it first 0 by or infinity into infinity form. So we have to make it 0 by 0 form. We make it 0 by 0 form by it is infinity into 0 form, so we make it infinity 0 by 0 form. How we make it? Limit x tends to 1, log 2 minus x whole by we take this down, then it becomes cot pi x by 2. This is 0 and this is our 0, so it is 0 by 0 form. Now what we can do, we can simply take out different derivative upside and downside. 2 derivative of 2 0 minus x derivative is limit x tends to 1, derivative of this is 1, so minus 1 upon derivative of cot x is cosec square x, so cosec square by x by 2. Now we put the value of x is 1. This offside, when it goes offside, then limit x tends to 1 minus sine square pi x by 2. When we put the value, then it becomes sine pi by 2, sine 90 is minus 1. So what we get, log y is equal to minus of 1, so it becomes y is equal to e raised to the power of minus 1, which is our answer. Now we move to our fourth question, which is from asymptotes, and the question is asked. This is the question number 4 from asymptotes. So we are going to solve it. For x square plus 2xy plus y is square, x plus 2y plus 2 minus x minus 9y plus 2 is equal to 0, or x square, x it is x cube plus 2y x square plus 2x square plus 2x square y plus 4y square x plus 4xy plus of xy square plus 2y cube plus 2y square minus of x minus of 9y plus 2 is equal to 0. We are going to bring them together. X cube, only one x cube is present, and 2y y x square. How many y x square are there? X square y 2, 4x square y are there, and x square, only one x square is there. And how many y square x are there? Y square x, there are only 5xy of square plus xy, only 4xy plus 2y cube only, and 2y square minus x minus 9y plus 2 is equal to 0. Or now we are gonna range for good. We are gonna range to make it little standard. X cube 2y cube in the decreasing order plus 4x square y plus 5xy square plus 2x square plus 2y square minus x minus 9y plus 2 is equal to 0. Since maximum order is 3, so there are at most 3 asymptotes. Now we are ready to solve for asymptotes. So there are 3 asymptotes. Since y cube is present, here we can see x cube is present and y cube, x cube is present, y cube is also present. So y cube and x cube are present, so no parallel asymptotes are found. So for oblique asymptote oblique asymptote put x is equal to 1, y is equal to m, let y is equal to mx plus c be the oblique asymptote, then what we can just write, then we can take phi 3 of m, phi 2 of m. If phi 3 dash of m is needed, that we can find later, or now also we can find phi 3 of m, that is third order. Here we paid value of x is 1 and y is m. Now what we get, x cube 1, x cube 1 plus 2m cube plus, therefore x square we put 1 and y is m plus 5m square. These are only of 3 order and of 2 order. What are of 2 order? We can see 2 order, x square y square, and that is 2 plus 2m of square. In 1 order, minus 1 minus 9m. Now what we can see, we have written phi 2 and phi 1m. So for m, to find value of m, we have to do phi 3 of m is equal to 0, or 1 plus 2m cube plus 4m plus 5m square is equal to 0, or 2m of cube plus 5m of square plus 4m plus 1 is equal to 0. Now you have to solve the equation. How you can solve? As before, you can solve the equation, put the value of which source the equation, plus 1. When we put plus 1, then it will not solve, because we simply see all are in positive, then it will only add up. If we put minus here, minus, this will be minus and this will be minus, because odd power 4, 5, 6 and 5, 6, it will be 0. So when we put minus 1, it satisfies. So x minus 1 may be the equation that satisfies. Then minus 1 comes on the right hand side, then it will be plus 1, that is x plus 1 or m plus 1 in this case. So 2m cube, to make m plus 1, m plus only 1, so we write this now, m plus 1 is m plus 1 is remained and other is taken as common, plus here remained 2 and 5, 3m square plus 3m plus 3m and 3 and 4, it is m plus 1 is equal to 0. Or now what we can see, 2m square is common, m plus 1 plus 3m is common, m plus 1 and plus 1 is common, m plus 1 is equal to 0. Or 2m square plus 3m plus 1m plus 1 is equal to 0. Or for this, what we can do, we can do 2m square plus 2m plus m plus 1 is 1, m plus 1 is equal to 0. This is m is equal to 0. Or we can simply write 2m will be common, 2m from here 1 would be common, plus 1 and m plus 1, m plus 1 is equal to 0. So we have got the value of m is equal to, this becomes minus 1 by 2, or here we'll write it up here, m is equal to, we have got to be minus 1 by 2 comma minus 1 comma minus 1. So we have got two values of m, it's same and one value different. So we find this for same value and for different value by using two different formulas. what we have got formulas for m is equal to minus 1 by 2. This is different from others, so we will use different formula. C is equal to phi 3 minus of phi 3 m upon phi 2 dash m is equal to, this is for different, and for m is equal to minus 1, there were 2 minus 1 as you can see previous, so we use same for this to next formula for this when it is the same. So c square by 2 factorial phi 3 double dash of m c by 1 factorial phi 2 of m plus phi 1 of m is equal to this. This is next formula. Now we find the value of c from both. Phi 3m, put value of m in the phi 3 equation, then you will get the value m is minus 1 by 2. Here also same. Phi 2 dash you have to find first derivative, here you have to find second derivative, and this is same. Then we find what is the first derivative. We have to find first phi 2 dash m is equal to, and we have to find phi 3 double dash m is equal to, then we find this. So these two can be found. So now we do what we do for calculation. We go toward calculation. First we will do this phi 3 of m minus phi 3 of m. When we put the value of m to be minus 1 by 2, then we get phi 3 m is, so we get the value is minus there and 3 by 2 and phi 2 dash. We will get as phi 2 dash, how many we get? We will get minus of 6, so it would be 3 by 2 minus 3 by 2 would be, so our phi 2 m would be 4 into minus 1 by 2, 4 into minus 1 by 2, it would be minus 2, so it would be minus, you can say, then it would be 2 by 2, 3 by 4, 2 by 4, this is 3 by 4. Now we solve for this, or c square by 2 factor or 2, it is 2, phi 3 double dash of m we have found, minus of 2 and plus c phi 2 of m, phi 2 dash of m, phi 2 dash of m is minus of 4 plus phi 1 m is 8 is equal to 0, or c square minus c square minus 4c plus 8 is equal to 0. We take minus on the other side, plus 4c minus 8 is equal to 0, or it is 0. So we have to do what we have to do. We have to find the value. So to find the value of c, I think something is being missed here, so we are going to check it. Your 4xy is missing, so we add here plus 4 of xy, which this is second degree, so we go to the second degree, plus 4m, and from here phi 2m we all change phi 2m, we change phi 2m. Where is phi 2m? Here phi 2m, phi 2 dash m we will change here, and phi 2 dash m we will change here, so it becomes, so our phi 2m, phi 2 dash m, when we put this value of m is minus 1 by 2, it will be it would be 1 by 2, it would be 1 by 2 minus, it would be 1 by 2, so the value of c would be 3. Now when this value changes here, I have already changed the value, so phi 2 dash m would be 0, so this is 0, so this is 0, so this is 0. So the value of c is 2 root 2, plus minus 2 root 2. Hence equation of asymptotes are: first, y is equal to, our value of m is 1 by 2 x, and c is this. From here what we get, 2y plus x, this LCM would be 6 plus 6 is equal to 0. Or we have next is y is equal to m we have minus 1x, and c we have found to be plus minus 2 root 2 here. So we get the value is y plus x is equal to plus minus 2 root 2. This is our answer, and this is our answer. Now we are gonna move to question number 5, which is from equation, like pedal equation. I have forgot the actual name of the chapter, and this is asked. This question is asked in the 74th Chaitra, and it has asked to find the pedal equation of the curve. How are we going to do this solution? For this we have to let curve passes through b sin phi comma a cos phi. Then we have to find slope of the curve is 1 upon a square 2x plus 1 upon a square 2y. y1 is equal to 1, or 1 derivative of 1 is 0. So we get slope of y1 as when it reaches to the next side, it becomes a square by b square minus of x by y. So this is our equation of slope. 8 b sin phi comma a cos phi would be our equation. Would be, when we put the value of this as b sin phi, b will cancel, and a would be cancelled, so minus a by b sin phi by cos phi would be sin phi by cos phi. Now we have found the equation of the tangent is x minus b sin theta slope is minus a by b sin phi by cos phi. This is phi, so this is also phi, is equal to y minus a of cos phi. Or what we will get multiplying this, minus ax sin phi plus ab sin square of phi is equal to by cos phi minus ab of cos square phi. or we will be getting minus a sine phi x minus b cos phi of y plus ab, and sine square, when this come here it will be 1. So this is, now what we have got this. So we find length of perpendicularity is p is equal to, we put the value of x and y is 0. You can ab by root over of a sine phi a square sine square phi plus b square cos square phi, or when we square it, p square is equal to, or p square a square sine square phi plus b square cos square phi is equal to a square b square. Or now what we do, we know x square plus y square is equal to r square, or r square is equal to x value. What we have got, x value we have got at b sin theta, so b square sin square phi plus a square cos square phi. This is the value of r square. So now a square b square by p square, from above we get a square sin square phi plus b square cos square phi is equal to a square minus a square cos square phi plus b square cos square phi is equal to b square a square cos square phi b square sin square phi. We have got that. So what we can just write is we're gonna change this in form of sine, because this a is with cos and b is with sine. A cos, b will be with sine. So plus b square minus is taken common, cos square phi, or a is missing, a square cos square phi plus b square sine square phi, and this can be written as r square. So a square plus b square minus r square, or a square b square by b square. Or now we divide by a square b square on both sides. What we get, 1 upon p square, or a square b square by r, a square b square r square. P square r square is equal to 1 upon b square, 1 upon b square r square p square plus 1 upon a square or p square r square minus 1 upon, what we get, 1 upon a square b square p square. Or we can write answer in form of 1 upon p square only dividing by a square b square, 1 upon b square plus 1 upon a square minus r square upon a square b square. This would be our answer. Now our derivative part is finished. Up to question number 5 it was our derivative part which is completed.